2 years back, the U.S. military shut down its program. They said it was too unstable and unreliable. Are we stuck with the languages we have now because of where we are? Using Einstein's equations on wormholes, AI research found something unexpected. Data patterns that don't fit our universe. Scientists decoding signals from space spotted strange things. First, they thought it was a mistake, but the patterns kept showing up, pointing to physics that shouldn't exist, unless they're from another universe. Some now think we've found a parallel world, right next to ours, but just out of reach, a game changer in physics. In 1957, physicist Hugh Everett changed how we see reality with his many worlds idea. Instead of one single outcome, Everett thought every quantum event makes new universes, parallel worlds where everything that could happen does. This challenged the old view of one set universe and brought up a huge cosmic scene with endless versions of ourselves. Building on this, physicist Max Tegmark made a system for sorting the multiverse. His level 3 multiverse is exactly like Everett's quantum idea, where universes split all the time at every quantum choice. Also, string theory and brain cosmology hint our universe might be one brain floating with others in a bigger space, each with different physical laws and realities. Michio Kaku, a science communicator, says these multiverses come from string theory and the universe's inflation model. Still, the big issue is, how do we find real proof? Cosmologists are still arguing if parallel universes can be seen, or if they're forever out of reach. Kaku says the multiverse is the last frontier, exciting and annoying. Understanding parallel universes sets for how tools are pushing what we know, with AI now playing a big part in this story, changing how we look for hidden realities. AI is changing physics, especially in going through huge amounts of space data that people can't handle alone. One example is how it spots gravitational waves at LIGO. AI finds tiny ripples in spacetime fast, which were hard to find by hand. This speed has opened doors to the universe's biggest events. Besides gravitational waves, AI is used on the cosmic microwave background, CMB, the Big Bang's afterglow. Machine learning shows small temp changes and patterns in the CMB, which might hint at early universe events or signs of other universes. At CERN, AI helps physicists look through particle collisions, searching for signs of new physics that might match multiverse guesses. Quantum AI is pushing this further, using quantum computers to solve hard problems, maybe finding quantum mechanics secrets. AI is like a detective, sorting cosmic noise to find clues, signals that might be from parallel universes nearby. With AI finding hidden signals, what has it found? Let's look at the new data that hints at worlds beyond ours. Recent AI analysis of LIGO's gravitational wave data and space stuff has found weird things. These signals don't match known space events, like black hole or neutron star crashes. So, researchers think these leaks might be proof of our universe talking to others, or effects from extra space, like string theory says. Places like the Perimeter Institute and MIT are checking these signals closely. They're making sure it's not just noise before thinking about big answers. Though it's not direct, these things across data sets suggest something new is up. Scientists are being careful. One physicist said, "We need good proof for big claims." These hints are interesting, but not proof. Still, the data has opened a new way to study the multiverse. Since we get the data hinting at parallel universes, we have to explore the science behind these signals, how theories explain them, and what else could be. The signals found by AI are interesting because they could match physics ideas. String theory says our universe is made of tiny strings and predicts extra spatial dimensions. Our universe could be a brain floating in a bigger space. Sometimes brains might hit each other, making effects like the signals we see. One idea is the periodic universe theory. It says our Big Bang wasn't the start, but crashed between two brains in bigger space. This could leave marks in our universe that detectors might see. Quantum entanglement, where particles are linked no matter how far, messes with old ideas of locality. Some think info could flow between parallel universes through linked particles, making a bridge between realities. Not all weird things have to be strange. Some might be from space events or instrument mess-ups. Scientists are still careful, comparing normal answers to crazy ones. Researchers are working to confirm where these signals come from. Let's see how science is trying to prove the multiverse. The search for parallel universes is entering a new time because of new instruments and teamwork. LISA and the Einstein telescope are next-gen gravitational wave detectors made to see weaker signals. These places might find problems from crashes in bigger spaces or universe brain talks. At CERN, they're planning to boost particle accelerators to reach where extra dimension effects might show. Finding new particles or forces could hint at universes in the same space stuff. NASA's James Webb Space Telescope and future space missions will look at space closely, searching for multiverse marks, like weird things in space background radiation or strange galaxy patterns. Also, quantum sensors and atomic interferometers are being made to measure small leaks that might signal hidden universes. These spacing ripples could prove the multiverse. Astronomers, particle physicists, cosmologists, and quantum engineers are working together, sharing knowledge. It's people trying to turn ideas into science. As the quest to prove parallel universes moves forward, its effects go beyond physics, changing how we see ourselves. The multiverse raises issues about identity. If versions of us live in worlds, what about free will? Philosophers argue if each you is a separate mind or part of a bigger multiversal self. Religious people are dealing with multiverse effects. Fate, the soul, face new ideas when realities exist. Some say this could spiritual views, while others see it challenging beliefs. Shows like Stranger Things have multiverse themes, shaping public thought and making physics easy. If contact between universes was possible, there would be ethics issues. How would it affect reality? Should we mess with other worlds? These questions are speculation, but show the multiverse's effect on how we think. Ultimately, the multiverse asks us to see ourselves as part of a huge cosmos. The multiverse expands not just science, but our wonder before the universe. The idea that we live in a multiverse has made scientists excited and cautious. Stephen Hawking and Neil deGrasse Tyson have said we need proof before believing it. One expert said the multiverse is a good idea, but needs to be based on data. At the same time, people are into parallel universes because of headlines. This news oversimplifies findings, leading to wrong ideas. Many news sources have said the multiverse is real, not a theory creating expectations. This suggests we need science understanding. Groups like the AS stress clear communication to help people get what multiverse research is about and why being skeptical is good. Open talk between scientists and people is needed to stop wrong info and keep trust. The hints show a shift in research funding. Governments are putting money into physics projects that could explain reality, including multiverse studies. With more money comes responsibility to keep peer review and openness and respect discovery and science. This balance is optimism and thinking. One researcher put it, "We are at a place where hope meets skepticism for science to grow." With the public dealing with these things, what's next? How might multiverse research shape physics and space? Multiverse research might change physics and our worldview. Quantum computing could use parallel universes to process info across realities at once, unlocking computer power. Communication tech might also change with quantum teleportation, inspiring new ways to think about information transfer. This could change communications and data processing. Understanding the multiverse could answer space questions. Dark matter and energy, which make up the universe, might be explained if they're influenced by others. This will guide particle accelerators and telescopes to find multiverse signals, like weird things in space radiation, or new particles. This is ongoing. The search for parallel universes mixes theory in a loop. A physicist said we stand on the shoulders of giants looking into the multiverse, unsure of what's next, but driven by wonder. Beyond the science, these touch on human themes relating to our place in the cosmos, also touching on culture, ethics, and wonder. The multiverse goes beyond science into culture. Stories about multiple realities and books shape society's thoughts. These also bring questions. If technology lets interaction between universes occur, how do we handle the consequences? This puts philosophers to new moral reasonings that on a personal level, the multiverse makes us think about ourselves. If multiple versions of yourself exist, what does that mean to responsibility?